Hi Spring fans, welcome to another installment of Spring Tips. In this week's installment, we're going to again revisit RSocket. Now, in a previous installment of Spring Tips, we looked at RSocket, wherein I introduced the protocol RSocket and the client-side library developed by Facebook in built upon Reactor, right? And so in that video, we looked at, let's say, raw RSocket, right? Just a low-level RSocket. And I foreshadowed the idea that one day, one sweet day, we'd have support for RSocket in the Spring framework itself. Well, that day has come at long last, my friends. And so what I want to talk to you about today is how to use RSocket with Spring and to look at what are the opportunities here. Now, a quick revision, I think, is in order. RSocket, at the end of the day, is a protocol. It's a cross-platform language-agnostic protocol that was designed by Facebook with input and design from people who came over from Netflix on how to build highly available microservice-centric systems. And the goal here was to provide an application protocol, an application use case-centric protocol, right? As opposed to HTTP, which you might differentiate and call, for example, a document retrieval protocol. And these use cases are orthogonal. The one I think complements the other, but they are not the same thing. And so it's for this reason that this protocol was necessary. There are a number of different limitations with HTTP that just don't make it a great fit for homogeneous communication. Obviously, the biggest single differentiating feature is the interoperability that it extends to people who are using the open web, and that's not to be ignored. Of course, don't sleep on that particular feature. But if you wanted to support some of the more common message exchange patterns, for example, request response, that's pretty natural to do with HTTP. But what about fire and forget? Right? How do you send a message and then ignore the response and get the performance optimizations on both producer and consumer associated with that exchange? What about requesting or sending a value and then getting a stream of values back, an unending stream? This is certainly possible with service and events, but service and events, as well as WebSockets, they don't have headers, right? There's no way for a stream level sort of message, there's no way to perpetuate a token, for example. So this use case is one that's just not well served. This is one use case that's just not well served in our application and in the protocol itself and the platform. Another thing that's sort of interesting is, what about bidirectional streaming? Like, how do I do, ongoing communication? And again, you can use WebSockets for that, but again, that has some limitations. And it certainly doesn't solve the sort of question of how do I have something that's initiated by the server, right? Why does it have to be the consumer that makes the request and then initiates the discussion? Why can't it be the other way around? And so for this use case, we need something a bit more sophisticated. And when I say sophisticated, I don't mean something new, right? We've already got TCP. We've already got this mechanism that allows that. It's just a little low level, and it's fairly easy to shoot yourself in the foot with that low level sort of transport. So that's one thing. Another thing is the RSocket is agnostic of payload. It doesn't matter what you want to send across the wire. It's binary data, and you can conduct anything you like across that transport. It could be a JSON string. It could be binary streams of video or data or whatever. But it's up to you, right? So with HTTP, how do you send an image? Well, you base64 encode the binary data, and then on the other side, you unbase64 encode it, and you read it into binary data. This, despite the fact that ultimately HTTP is, behind the scenes, there's binary, right? So you go from binary to the textual representation that HTTP requires, which then gets you to the base64 thing. Then you go back to binary, and it's just super inefficient. So, these are just sort of things that we want. Another thing that RSocket gives you is a built-in frame in the protocol proper that allows you to communicate availability, right? That is to say, the client can ask the consumer can ask the producer, how much uptime do you have? What is your health, right? With Spring, we've got the Spring Boot, we have the actuator module, and that module hangs off the side of your web application, off of JMX or HTTP, and it communicates just that kind of information, that out-of-band availability information, right? That out-of-band health information, metrics, things like that. Things that the client, if it knows about it, can look to sort of decide whether it should reroute itself to another node, right? Or some sort of intermediary infrastructure can also decide whether that service is sick. Well, this is something that has to be arranged, right? It's an agreement between the Spring Boot convention of having the actuator and the engineers and the infrastructure, etc. Well, now that problem goes away. Now it's built into the protocol proper. There's every expectation that you will want to ask this question and have an answer. So we get a lot of benefits by using RSocket. RSocket doesn't have a few things, right? If you're using regular, just low-level RSocket, as I introduced in that first video, you'll notice that there is no, for example, no support for routing, right? What does it mean to route? Well, when a client connects to a port, you have an open connection, and that's it. How do you divide the logic? How do you divide the business logic into different handlers? With HTTP and Spring, it's very common to say, okay, I've got a handler that lives at a certain path, the URI, and that helps the web framework determine what component to invoke in response, right? Well, there is no obvious sort of support for that out of the box with the protocol proper, but Spring and our new messaging model provides that. The message mapping annotation, rather, provides that. Another thing that there's no support for out of the box, because it's agnostic to this particular use case, is how do you conduct payloads? How do you send bytes from point A to point B, right? In RSocket, you send anything you want, and there's no way to sort of figure out what the content is. You have to kind of encode that in the headers, which you can do, but we do that for you. We can do message conversion in the Spring RSocket support. So let's take a look at that. Now that we've kind of got a feel for what is there and what isn't there, and we got a feel for what's possible, let's go ahead and build a new application, as always, using my second favorite place on the internet, start.spring.io. I'm going to use Spring Boot 2.2.0 snapshot. I'm going to build two modules, producer and consumer. I'm going to use the RSocket support. That checkbox, by the by, only works in the latest and greatest. I suspect it'll be available for 2.2.0 M2, but for now, I'm just going to constrain myself to 2.2 snapshot because it's there for that. It's not there for 2.2.M1. Okay, so I'm going to use reactive web as well. Let's see, and that's it. That should be enough for us to have everything we need. I'll bring in dev tools, and that's the producer. Hit generate. We'll do consumer. Hit generate. All right, and now UAO producer. All right, and now we have our consumer that's over here. So UAO consumer, and we're gonna keep the producer on the left and the consumer on the right. On the producer side, we're just gonna build a RSocket service. There's no HTTP involved, so I'm gonna go ahead and comment out this bit right here. There we go. Okay, so now we've got two sides, two applications. Let's close this out. Here's the producer, and here's the consumer. And we're just going to develop these things in tandem. Now, the auto configuration for Spring Boot will set up the producer side. It will set up a RSocket server for us, assuming I specify a port. So RSocket port equals, let's say, 7000. And I'll do lazy initialization. Great. And there we go. So there's our RSocket server. We can start that up. On the consumer side, I'm going to use an RSocket requester. And the auto configuration doesn't provide that for us, but it provides most of what we need, so we can just depend on that. So I'm going to create that here. I'm going to create an RSocket connection, and this is, again, fairly, this should be familiar if you watch that first video. So I cannot stress enough how much you should watch that. So TCP client transport, and start.block data. We want the data mime type. That'll be mime type utils, application JSON UTF-8, and we want transport. We already got that. What else do we need? Frame decoder, payload decoder, 0 copy, and that's that. And then we're going to use a RSocket requester. This is like the web client from Spring Web Flux. RSocket requester. Okay, I'm going to inject the RSocket reference, and we're going to use mime type utils.application.json value, and then finally we need the RSocket strategies object that Spring's auto configuration will automatically create for us. Okay, so let's put that in there, and this doesn't need to be a value; it needs to be the actual, object. Okay, good. So we've got all that now in one place. We can build a client that will talk to our service, and our service is just a regular controller. I'm going to call this the greetings RSocket Controller. Okay, I'm going to have an entity of type class greetings request, class greetings response. Okay, and our request will have a name that we're going to greet, and this will have a greeting. Okay, very, very simple. Now, I want to data at all args, no args, good. Add these compile time annotations, good. Now, here, we're going to create a builder here, so it'll be a greetings request with greeting. Okay, string message, return this after I do this dot. Sorry, I want this in the response, don't I? Greetings response. Here we go. Good stuff. So this dot greeting equals message. Create a constructor here for the common case, which is one that we'll see. It'll take a name and it'll produce a response for us. So we'll say this dot with greeting hello name at instant dot now. All right, this is a response. Good stuff. Okay, so if you give us a name, we'll create a default thing for you. If not, you can use the builder. Okay, so there's no argument version of that as well. Okay, so there we go. We got that. Now, I've got the ability to create a response quickly. I've got the carrier, the DTO for the request, which has a name. Now I'm going to copy and paste that for easy interoperation to the other side, to the producer and the consumer. So now we both have the same types. Obviously, you would need to, extricate that somehow. You store it in a mutual shared library or something like that. Or not, right? Again, you can just create your own client-side representations if it's trivial enough. Who cares? So now we've got the types. Let's create our controller here. Okay, and the controller is going to have. Let's demonstrate the absolute simplest thing that could possibly work first. So message mapping greet. Okay, and all we're going to do is we're going to return a single string. Sorry, not a string. A greetings response given a request that is of type greetings request. Okay, and new greetings response. Okay, and it'll be request.getName. So that's the absolute simplest one that could work. And you can see that this is not a path per se. Like I said, the routing is now something that Spring provides. We're saying this string, this label, greet, maps to this logic. If you want to invoke that, something has to communicate that string in a way that will be understood. And the RSocket requester will do that for you. So what I'm going to do here is I'm going to create a client that is actually just a REST controller. So we can actually invoke them in the browser and see the results. Okay, so greetings REST controller. All right, and this will have an endpoint called greet, and I'm going to say publisher of what? Greetings response greet path variable string name. I'm going to say this dot greet. Sorry, this dot. We need a requester now, right? Requester. Add that to the constructor. This dot requester dot route, and it's just going to be greet. And I'm going to send some data. The data is going to be a new greetings request, right? New greetings request. and the request will have a name, which is going to pass in there. We're expecting a response back. In this case, it's just a single value, so we'll expect a mono of type greetings response, okay? And return that. So now we've got the service. Let's just make sure I've restarted that. I'm not sure when I last restarted it. Okay. And then here, we'll restart this. So now on the client side, running on port 8080, and you can see I've got the web server on port 8080. I don't have the web server over here because I got rid of the webflux dependency. I do have Netty RSocket started. On the other side, I don't have Netty RSocket because I didn't specify a port. So the consumer, the auto configuration kicks in, but it does everything except for start the web server, the RSocket server, which is good because I might want to, for example, use the configuration, but set up the transport to be the WebSocket support provided from our Spring WebFlux engine, for example. So you can actually do RSocket over WebSockets, for example. And the Spring Boot auto configuration can wire that up for you if you like. But the point is, you have to kind of opt in to these different features. And in this case, all I want is to act as a client. So for example, I want the RSocket strategies to get wired up for me, and I need a client RSocket reference. But other than that, everything is already provided for me. Okay. All right, let's see. So we go to localhost, greet world. All right, I didn't provide a name, did I? Where's my, oh, right, greet name, restart. Okay, there's my greeting. As I refresh the browser, you see the timestamp increasing ever upward. Okay. All right. So that's in and out. That's just one value in, one out, value out. Behind the scenes, these values are being sent around as payloads. Well, of course, you can do streaming as well. So, for example, let's say I wanted to have an endpoint that was a server sent endpoint. So produces media type, right? Type dot text event stream value is greet SSE name. All right. So publisher of greeting response, path variable string name. And here we're going to use this thing to greet, stream. Okay, we're going to call the greet stream endpoint. And the data we're going to send, as before, is this. I'm going to get back to that. Okay, so just replace. All right. So retrieve, in this case, a flux of responses. And so I'm calling the RSocket endpoint using the RSocket requester. We know that it's pointing to port 7000 because that's what we specified there. Now on the server side, I need to actually provide this endpoint, the greet stream endpoint. So I'll do that. I'll say at message mapping flux of greetings response, greet stream, greet request, and our job is to say flux dot from stream dot generate new supplier, and then dot delay elements duration of seconds. We're going to stagger the results. You've seen me do that when I introduced service and events, for example. So new greetings response, and then the name we'll get from the request. So as before, it's just that now we're going to iterate, and we'll provide many values that'll have incrementing timestamps. All right, so same thing. Greet stream. I'm going to send back a publisher of greetings response whose results will be staggered every 1 second. We'll get a new one. Okay. Okay. Now we go here to greet stream. What did I say? I said SSE world. There you go. So we're streaming data, right? We're actually streaming data over the network here, not using HTTP or anything like that. The gateway, we have a node that is the consumer. It's got a client. and the user interface is the HTTP API, but the actual logic, the actual data is being streamed from the other RSocket server, and we're getting it, and it's reactive back all the way through, so I get all these nice operators, and I can use back pressure, and I can do all that. This is, I think, a really nice sort of arrangement, right? You can actually do some very interesting things, and this is not more difficult to express than the HTTP stuff. Quite the contrary. It's actually easier. And you have some, it's Spring, so you have, for example, if you want to handle errors, you have a nice way to do that. You can say, okay, well, let's say I wanted to return a publisher of greetings responses error handler given a legal argument exception, IAE. Okay. So flux.just new greetings response dot with greeting. Oh no! So if something goes wrong, if a endpoint throws an illegal argument exception for whatever reason, then this will get called, and I'll have a chance to provide the response, the default response that I want, rather than having it bubble back up to the user. And so let's create that endpoint here. Message mapping error. Okay, it'll be a flux of greeting response error, and all I'm going to do is I'm going to say return mono.error new illegal argument. So it's going to be flux.error. There you go. Okay, so that's my error endpoint. On the client side, we'll just create an endpoint that we can call. So error publisher greeting response, and we'll start this, of course. On this side, we'll say error, and this dot requester dot route error dot retrieve. I'm going to send nothing in the payload, so it'll just be mono.empty, I guess, and then retrieve whatever, right? We don't care. Greeting response dot class, and then we can restart the server. And in the browser, go to error, and it says, oh no. So we actually got the default fallback value that we wanted, right? That's actually very useful. So now we've got RSocket. We've seen how we can use the message mapping facilities in Spring Framework 5.2 and Spring Boot 2.2. We've looked at how to expose endpoints using the message mapping annotations. These are fairly familiar if you've ever used the WebSocket support in Spring. There's still some more work to be done, and things are exciting. I'm excited to see this land in Spring Framework already, and work has already been afoot and is surging ahead on supporting RSocket and Spring Cloud Gateway. So the RSocket support in Spring Cloud Gateway, well, you can imagine some of the possibilities here. You can imagine, for example, having a server that's completely locked down, it's a black box, and then it initiates a connection to the gateway. And because you can have stateful, long-lived connections that do duplex kind of communication, that gateway could maintain open connections from each of the microservices, which reach out to the gateway, right? So the gateway isn't connecting to the microservice; it's the other way around, and there's no ingress into those microservices, so they're imminently secure. And then they have the ability to, the gateway could, for example, be the router. It could say, oh, well, I have this connection to this microservice open. I asked it. It has enough capacity, enough availability, enough uptime, enough health, whatever. So I'm going to route the request to it, right? So it can do that. I mean, it has the ability to ask that question and then seamlessly, move streams from one node to another, right? So lots of really interesting possibilities here. The best is yet to come, as always, but I hope you give this stuff a try, feedback, and let us know. So with that, my friends, thanks for watching, and as always, we'll see you next